Today we're going to solve this circuit using Kirchhoff laws. And to solve it, we first need to set up the Kirchhoff equations. And as a second exercise, we will solve the amount of electrons through this point A, but we'll ignore this point for now. So let me set up the Kirchhoff equations. For this we need 2 loops and 1 node. First start with the node over here, number 1. Then we have a loop here, which I call 2. And another loop here, which we call 3. So we have node 1, loop 2, and loop 3. Okay, so first we're going to solve node 1, and after this we will look at loop 2 and 3. But let me start with 1. Here we have current I2 coming in, and current I1 and I3 leaving. So we can write this as I2 is equal to I1 plus I3, where we have I1, the incoming one, and then I2, the incoming one, and then I1 and I3, the outgoing ones. And we will use this later to fill it into the second loop, because as we look at loop 2, we now have to look at voltages, because we are looking at a loop instead of a node. So we have the voltage V3, then the voltage dissipated through R3, the voltage dissipated to R2, and we have V2 as well. So let me start as V3. Then we look at the voltage through R3. We have to use a minus sign because it is dissipation and not added up. Minus I3 times R3. The same goes for R2. Minus I2 times R2. And then again add up for V2 plus V2. And this is equal to 0. Now, as I said, we can fill in I2 here. So let me fill in the first equation in here so that we only have I1 and I3 and I2 is left out. And what I will do at the same time is I will get the V's to one side and then the I's to the other side. So first we have V2 plus V3. And this is then equal to I3 times R3 plus I2, where we fill in I1 plus I3. And this times R2. Now, what I would like to get out of this is an equation for I3. So let me get these I3s to one side again, and then move this I1 to the same side as the voltages. So first we have I3, and this is times R3 and times R2. And then we have the V's. So this is equal to V2 plus V3 minus I1 times R2. So let me check if I have all terms. We have I3, R3, 3 from here, I3, R2 from here, V2, V3, and then the minus I1 times R2. And yeah, so now we have, if we move this to the other side, we have an equation for I3. So let me do that. Is equal to V2 plus V3 minus I1 R2 divided by R2 plus R3. Yeah, so now we have the first two equations. Let's give me some space to erase this, and then we only leave these two in here. So here I wrote down our equation for I3. And now we can move on to loop number 3. Our final Kirchhoff equation. Here we again have I3, R3, V3, R3, R1, but this is against the current, and V1. So let me start with V3 again. V3 minus I3, R3. And then we have plus I1, R1, since this is against the current. And then again minus V1, as this is also against the current. And this is also equal to 0. So here we have the second Kirchhoff equation, and let me put these v's to one side, and then we can fill in I3 that we found here. So first we have V3 minus V1. And this is then equal to R3 times I3, which I get from here. V2 plus V3 minus I1 R2 over R2 plus R3. And then we're still left with this I1 R1, which we also took to the other side. So minus I1 R1. Now you might notice that we only have, as an unknown, we only are left with I1. So I would like to take out here I1 to get an equation for the current. And let me start with I1 then. This is times R1. And then plus this term. So it might be a bit difficult to see, but I will take out this R2, R3 over R2 plus R3. And we have also a plus sign here since I took it to the other side again. So we have these terms to this side. Then we are left with the R3 times V2 plus R plus V2, V2 plus V3. And then minus these. So minus V minus V3 plus V1. So let's have a look what I did here. We have the I1 times R1 plus I1 times R2, R3 over R2 plus R3. And then here we have the R3 times V2 plus V3 over R2 plus V3, R3. And then we have the V's over here. Now, if we take this to the other side of the equation, we have an equation for I1. Now, at this point, we have two options. We can further simplify this equation, but we can also notice that here we have all the numbers we need. So we can just plug this in and then get the number for the current I1. I already did this previously. You can check me. This is equal to 0.16 amps. Next up, we still need I3 and I2. And as you can see, here we already have the function for I3, sorry. And we have now also I1. We found I1. We have all the voltages and the resistances. So here we can also see that I3 is equal to 3.2 amps. And then we simply have to add up these two to find I2. And then I2 is equal to 3.36 amps. So here I've summarized our currents we just found. I've rounded them off. And now to give you some better idea of the physics behind this, we are now going to look at point A. And my question is, how many electrons actually run through this point in a time of 3 seconds? So we have T is 3 seconds. And what is important to know is that actually current running here is just electrons passing through. And we know the charge of one electron, which is called E. E is 1.602 times 10 to the minus 19 coulombs. So the unit of current, amps, is the same as coulombs per second. And to find, we have current I1. What is important is that actually electrons are negative charged, so the current is in this direction, but the electrons move in this direction. And then at point A, we have the number of electrons N, which is equal to the current, I1, divided by the electronic charge, so that we have the exact number of electrons as the current, and then also times the time, such that we get a unitless amount, which is actually just a number. And this is equal to 3.0 times 10 to the 18th electrons. So actually a small current is not that small if you equate it as a number of electrons running through. So good luck with your exercises and we'll see you next time.